And let's get started. All right, everybody. What we're going to be tackling down today is going to be the school assignment exercise. I have all three parts here inside of this documentation directory. I do have the data that is also being provided on the very first assignment that's there. I have my runner, and I have my school. Notice I don't have any other files. I don't have any other directories. This .dev container that came with the assignment. I don't need it. I'm just going to go ahead and quickly remove that so that it's not distracting me in any sort of way. All right. Let's go and take a look at the very first assignment here. All right, so the very first assignment is the school interface one. This is what we're going to build. So we're going to build a Richmond High student interface. This is going to welcome you to Richmond High. It's going to ask me, what would you like to do? Here are some options between 1 through 5. Go ahead and code it out. For this challenge, we'll be building a simple interface for a school. Great. I'm not going to bore you guys by reading this entire file to you. Note that there are data files. And here's what we're going to be building inside of runner.py. So here's my runner. It already has these lines of code. Fantastic. All right. And does it actually? Yes, it does. That makes me wonder. Oh, the school doesn't have anything though. So we need to fix that. All right. As I keep reading here, it's telling me, hey, inside of your very first portion, go ahead and create the school of class. It should look as such. We're going to make sure that it has a staff, which is list. We have some students, which is also a list, and that we are assigning a name. All right. And then it dives into being able to create some students and some staff. Notice that this very much also gives me the answer. This is more of a plug and play, but there's no fun in that. So let's go ahead and do it ourselves. So we can see that the school needs a name, staff, and students. Let's write that out. I'm going to go ahead and take my init method, where my init method is going to take in self. It's going to have a name, which will be a list of strings, and that is it. It will output a nice instance of a school. All right. For that, I'm going to have self.name be equal to name. I'm going to have self.students be equal to a list. Hey. See, this is the problem with Copilot. Or more like the problem with me for not knowing how to use Copilot. Let me put this thing to maximum sleep here. All right. There we go. So there's my self.staff, which is also going to be a list. Nice. Because I'm not taking this in through my parameters, I'm just going to go ahead and annotate it here that this is going to be a list, and this will also be a list. All right, go ahead, Mohammed.
I'm sorry, because I'm still not sure about the class level attribute. So why wouldn't we create the students and staff inside underneath the school in the class level?
Yeah, so in this case, I wouldn't actually pass in the students and staff into my init method. Rather, when a school is initialized, it should be initialized with a student body already inside it and a staff already inside it. And I think we're going to see that later on once we start working with the CSV files.
Okay.
Awesome. All right. Now, just to make this nice and easy, I'm also going to go ahead and account for a getter and setter, which is going to return self._name. This is a property. And then finally, I need my name.setter, which will take in name, self, a new name, which we know should be a string. This is going to output none. And I'm essentially just going to keep it nice and simple. I'm going to do if not is instance. I'm going to check that the new name is a string. If it is not, I will raise a value error stating, hey, not, or school name must be a string. Otherwise, I'm going to go ahead and do the whole self dot underscore name is equal to new name. And that should be my entire class of school. Fantastic. Now this should be set up. My runner is already creating a school and it's already printing the name. So I should be able to just run Python runner.py. And there I could see that I have Richmond High being printed into my console. So everything's working pretty well. I could take a further look at the school if I really wanted to. I could print something like school dot, and then I believe it's attributes. Let me see here. I know there's a dunder method that's going to show me all of it. I think dict will do it. Let's see that. There you go. All right. So there I could see that I have my actual value of a name. I have Richmond High that is being depicted there. My class of student is available and fantastic. And let's pay attention here. I have underscore name as a key with the value here. But if I go to school.py, there is no underscore name. So where's that coming from? Well, that is actually being managed through my getter and my setter. When I say, hey, I want self.name to be equal to something, that automatically triggers my setter. And I'm setting a value to self of underscore name with the value of name, which is Richmond High. All right. Any questions regarding this school? Let's hear it, Keith.
When you're putting on the getters and setters for the, you use the underscore. You don't have to use the underscore when you establish the attribute, the instance attribute, or is it, does it matter if you do it both, or can you just rely on the getter and setter to do it?
Yeah, that's a great question, right? What if I just do, hey, I just want to do underscore name right in here, right? Will this still function? Let's run it. So everything still works great. Fantastic. There's not necessarily an issue with this, right? I'm going to change this value of Richmond High, and I'm going to change it to 123. Well, now when I run it, hey, this actually worked. I didn't throw an error, and I totally expected it to throw an error, right? I didn't want this string to work. Well, the reason why it's working is because currently in my initializer, I'm not using my setter. The connection to my setter is broken. So anything could come in and anything could get assigned to name. If I actually want to enforce the fact that it's a string, I have to apply my setter. In order to do so, I would remove that underscore. And now I should get a value error telling me that school must be a string. Does that answer your question, Keith?
I see. So to get the setter to work, you need to have that pattern. Just establish the instance attribute, and then down in the setter, use the underscore in front of it.
Right. So setting the underscore should be happening within getters and setters.
Got it.
All right, Edward.
My mind always goes towards security and about like just edge cases about security and building like the application. So whenever you're trying to input like the school name, and if like this was on a user interface and the user decided to inject something into there, that's where this bug would fail, or that's where like this problem would arise because it was supposed to take a string, or it's supposed to take uh, that that I the naming convention, but it's then like switched over to that's where you expected it to fail, um, and it didn't fail and it passed. That's where like those like things can slip through.
Yeah, absolutely. Later on, once you get into web development and you're working within a server, this is going to be referenced to as a validator. And if you're talking about databases, this is actually referred to as a constraint.
Right.
All right, awesome. Okay, so we have our class of school set up. And now we can actually go ahead and keep moving through here to finish up the part one of our assignment, right? In the next part of our assignment here, what we have is we are actually going to start talking about a student. And a student has all of these attributes. Now, this is very nice that they were able to give me some sort of template here. But let's say this wasn't the directions that I received. And I know that I have to build student because that's the data that I received. I have a student and I have staff. All right. Now I want to keep my code nice and clean. So because I want to keep my code nice and clean, I'm actually going to create an entire separate file called students.py. And in this file is where I'm going to actually write all of my code. So I'm going to have my class of student, which is not going to inherit anything. And for now, I'm just going to write pass. And then I'm going to bring up that student CSV. Okay, so in my student CSV, here are the headers of the CSV file. Perfect. By giving me the headers of the CSV file, I can actually interpret what kind of parameters I'm going to need. So we know I'm going to need self, and then the rest of them are coming from my headers. All right. Self can come in. That's not an issue there. We know that my name should be of a string. We know that my age likely want to be of an integer. We probably want a role here where my role is of a string. We have our school ID, which seems to be an integer at a first glance. But if you take a look here, there's a couple of leading zeros. And if I turn this into an integer, it's going to fail, right? So this is actually meant to be a string that holds nothing but integers. So that's a pretty unique constraint there. All right, so I'm going to go ahead and say, hey, this is meant to be a string. And I indented my comma, now to go. And then finally my password, which is also a string. All right, so there's my initialization method. From there, I could go through the entire process of self.name is equal to name. We could do self.age is equal to age, self.role. And I'm going to continue doing this while I'm doing it. You could go ahead and ask your question, Jason.
Yes. So in the def init, prior we were just doing it straight across the board. Now you're like pushing it down like self, name, string, age, like that. Which one's better? Is it straight across or top down?
Yeah, that's a great question. There's not really a, hey, what's the best convention? It's kind of what works
Mhm.
best for you, right? You could see that I have this entire file. Typically, you don't want your file to run way too long. I think the
Mhm.
standard convention or like the popular convention is that a line of code, LOC, should stay within 50 to 75 characters.
Yeah, just to be clear, they do that is the idea is that it should fit on a standard monitor without needing to scroll.
Yeah.
Okay. Okay.
So instead of stretching it all the way out, you could just indent it. It works exactly the same. It doesn't change any of the functionality. It's just formatting.
Okay. Thank you. I was just curious about that.
Of course. All right, Simon.
All right, so Dom mentioned the other day about how these classes can be directly linked to when we start dealing with databases. And you said password is string. When we were dealing with the databases, passwords were varchar, or we also had big ints and we had different things. So is there a way to put that in there where it would be alphanumeric, or is it not? Is that kind of not necessarily the norm to have it where it's both numbers and letters?
Yeah, that's a fantastic question. So later on, once we're actually working inside of Django or another framework that supports a server, they're going to have a lot of built-in tools that you can use. A quick example of that would be something like Flask, right? Flask is not batteries included, so it has to reference called something, or it has to reference a package called SQL Alchemy. And then SQL Alchemy, I have to do this whole thing. Yeah. All right. SQL Alchemy is what comes in with a couple of models that you can actually use to define something. All right. So here it goes to the process of, hey, this is how you can create some tables. That's establishing some routes. Let me see here. Initialization, define models. There we go. So here's an example of how to define a model. Right? You could see there that they have integers and strings. In Django, what you're going to interact with is going to be something called Django ORM. And you'll take a look at some different model fields. You could see here that there's things like null, there's blank, there's auto, there's some big auto fields. Here's a Boolean field, the char field, which is the same thing as varchar. Um, and it just continues. There's quite a bit of many different things that are going to support this, but we don't have these resources currently available to us. So we have to write them from scratch with pure Pythonic code. Does that answer your question, Simon? All right, perfect. Okay, great. So now we have my student, and I may want to jump the gun and actually start doing some more information. Like I may want to just, hey, well, all of these is going to need getters and setters as well. Let's take a look at what else we have here. I'm going to go ahead and make a new one for staff.py, and I'm going to go ahead and code staff. Oh, that is not what I meant to do. Don't save that. All right. All right, so now I have staff.py available to me, and I'm also going to open their CSV file. Well, I'm going to go through the same process. Hey, I have my class of staff. This class of staff is going to have an init method. This init method is going to take in self. And afterwards, I'm just going to go ahead and bring in everything that I have in here. All right, so there's my init method. And it's pretty detailed, right? It walks me through my entire process of being able to accept the staff. But this should already start triggering something in your brain of, oh, well, wait a minute. I am violating a pretty good principle here, right? Which is the single responsibility principle. If we take a look at staff and we take a look at student, there is no difference between the two. If you compare this to one another, the only key value that changes or that is unique is school ID and employee ID. So what does that tell us? What other OOP concept can we apply? Let's hear it, Kaylee.
Oh, well, we want not to repeat ourselves, so I think we can make is it I want to say a subclass where we can put in these reoccurring values of name, age, role, and password, and then for student and staff we can reference that other we can reference the class that has the values of name, age, role, and password, so we don't have to rewrite them every time.
Nice. And what pillar of OOP is that?
That's inheritance, right?
Fantastic. So we're going to go ahead and grab inheritance, or we're going to go ahead and apply inheritance. So I'm going to go ahead and do this whole touch process here. And what I'm going to do is I'm going to make a people.py. And let's code that out. People.py. Now, people.py is going to look pretty much exactly the same thing as my student. Right there, I have my class of student. We're going to rename this to have people. And just like Kaylee said, all we need to worry about is all the commonalities. We're going to remove whatever is unique. And there it is. Here's my class of people. When it comes to getters and setters, where should I create my getters and setters? Should I create them inside of the people class that I'm going to be inheriting from? Or should I be creating them inside of the students and staff class? Let's hear, Edward.
Yeah, it should be within like the students and the staff class.
Okay, and why do you say that?
Because well, they're separate, and you have the dynamic IDs and you need to have separate um, people, well,
Okay,
students and staffs.
nice. All right, so I get where you're coming from, but in this case, because I don't want to repeat myself, I'm actually going to put it within the people class so that I can easily inherit it and not have to rewrite it multiple times. All right, so we can go through this entire process. I can go ahead and say, hey, at property, which we have the property of name, and let's just move this over here so that we don't have to share too much monitor. All right, so my property of name is going to take in self. It's going to take in a new name, and this should be of a string value. Oh, I apologize. I am jumping the gun. This should not take in a parameter. Instead, it should return a string. We can go ahead and return self dot underscore name. Here we can go ahead and bring in a name dot setter, where the setter of name should have self and a new name, which we know will be of a string, and it should return nothing. And here what we can do is do if not is instance new name and string. We can actually raise a value error where we have, hey, a name must be a string. Along with that, if that doesn't happen, we could actually say self dot underscore name is equal to new name. That takes care of my getter and setter for a name. Now let's move on to age. I'm going to go ahead and create my property. Here we have age that it's going to take in self. And this, as we discussed, should be an integer type. And it should return self dot underscore age. With that said, we should have a setter where that setter is going to accept an age value. I'm just going to call it val. That should be an integer, and it should return nothing. What we can do here is do the whole if not is instance. What we're looking for is to make sure that val is in fact an integer. And here we can raise a value error where we can state, hey, age must be an integer. Finally, we could do self dot underscore age is equal to val. All right, we move into role. So at property, and here I'm going to go ahead and do a property of role, which as we discussed should be a string. So we expect that to return a string, and we're just going to return self dot underscore role. Here we're going to go ahead and take role dot setter. We're going to define it. I see we have a hand up. Go ahead.
Shouldn't role be like given because the student and like the teacher? Does that make sense? Like I don't have to keep writing student.
I see. So you think that it should just be given every single
Yes.
time? Okay,
Yes.
awesome. Yeah, let's store that. I'm going to save that in the back of my head, and then we'll dive into it here shortly, right?
Okay.
So we have our role, which our role, we know that it should actually be either a student or a staff. So what we can do here is we can say if not value in student or staff, that we want to raise a value saying roles must be either student or staff. And then finally, we can go ahead and say self dot underscore role is equal to role. And I apologize, I meant to do val in there. And then finally, we have our password. So let's do at self dot password, or excuse me, this should be at property, where we have a password. This password should be self, and it should return a string. And we're just going to return self dot underscore password. Otherwise, we're going to use the password dot setter, which should take in self and a value of a string. We don't expect this to return anything. And we could do, hey, if not, is instance value and string. We want to raise a value error stating password must be a string. And we could just self dot underscore password is equal to password. Or excuse me, val. All right. Quite a bit of repetition there, but we have isolated our getters and setters, right? Ideally, if I have some sort of hashing criteria for my passwords that would go in there, I'm not trying to overcomplicate it and then take up too much of the lecture time. Roles must be one or the other. And we'll revisit what Mohammed has just brought up, as in it should just be given. Okay, and then we have some properties. All right, fantastic. Any questions up to this point? Let's hear it, Mohammed.
I'm sorry, one last question. I'll try not to ask again, but
Yeah.
shouldn't we create a function that like validate the string and we pass it inside like the password setter and the name setter so we don't repeat ourselves?
Yeah, we could definitely do that, right? We
Okay.
could just create a function that says, hey, let's see, def, say this could be a static method, right? So we could make this static, or we can make it a class method. And this class method is, hey, I want to validate that this is a string. And all it's going to do is it's going to take in CLS and it'll take in a value. And we probably just wanted to return a Boolean. Yeah, we'll return it a Boolean. Okay, so we'll say, hey, if not is instance, we do the whole value and string, then we want to raise a value error saying this property must be a string. And then otherwise we could return true. All right, so now anywhere that I use string, instead of having all of this, I can say, hey, if validate string or self.validate string, and we could pass in the value, then I want to say my password. And then this block of code would essentially become repetitive anywhere where I'm trying to validate string. Right, so great point for isolating code there, Mohammed. Does that answer your question? Okay, I see that answer your question. Thank you. Jason?
It doesn't matter the order of setters and getters when you're doing it, or is it set up a certain way? I know you draft property setters, getters and setters, but the order of how you set like name, row, that doesn't matter, correct? Or it does?
It does not matter. The only thing that
Okay,
matters is the getter must come before the setter.
getter before the setter, and the order of drafting them doesn't really matter.
That's correct.
Okay, thank you.
Of course. All right. There you go. We have our class of people. It's done. Now we're good to go. And we can actually start creating some students and we can start creating some staff. Well, let's start off with the student class. I want my student class to inherit from people. So I can say, hey, from people, I want to import people. Here I'm going to go ahead and conduct inheritance where I'm inheriting from people. And I'm going to remove everything that I don't need. All right, here I'm going to actually create my super method where my super method is going to call the initializer. In the initializer, we're going to pass in name, age, role, and password. Well, what about this role here? Do I really need to accept a role if I'm creating a student? Because the class of student should already be there, right? Well, I could remove it. Maybe I don't need a role. And then what I do here is I say, hey, this is a student. Does that address your question there, Mohammed? Perfect. All right. Well, now we could pretty much do the same exact thing. Come over to staff, where rather than utilizing student, we're talking about staff. And instead of school ID or student, we have staff. We have employee ID. And I see we have one more place where that is included. And that can get set now. All right. Now this employee ID, that probably needs a getter and setter as well. But I don't want to go and if I'm looking at them, the employee ID and the staff ID are managed pretty much in the same way. Let's go take a look at both students and staff. They are both strings with nothing but numbers inside of them. Let me see the staff one. Yeah, a string with nothing but numbers inside of them. Okay. Well, in that case, I'm going to go over to my people class. And in here, I'm going to go ahead and give myself another property here. This is going to be the handle ID property or getter and setter. So I'm going to name this a property. And I'm going to make it handle ID. I know it's going to take in self and it should return a string. From there, I'm going to return self dot underscore, and we're going to actually leave this as a pass. I'm just going to go ahead and create that here. But I do need a setter. So handle ID dot setter. This is going to take in handle ID, which is going to be self. And it's going to take in a value. And I could just create this into a method as well, but this works. This should be a string. And this is going to return none. Now, this one's a little bit more complicated, right? I definitely want to actually have some logic. So I'm going to say for, first of all, I'm going to make sure that it's actually a string. So if self.validate string and we pass in the value, then we're going to go ahead and run into our logic. I'm going to do a little bit of a linear search. So I'm going to say for character in val. If not, the character is numeric because it should be only a string of numbers. I should raise a value saying ID must be a string of numbers. Otherwise, I can say self dot underscore and yeah, this would have worked better as a class method. So let's actually turn this into a class method instead of a getter and header and setter. Let's turn that into a class method. All right, so handle ID. Here's my class method. It should take in CLS, not self. Okay, so it should raise a value. If it goes through this entire iteration, at the very end, it should just return the value. Well, now I can leverage this method, and it's available to both. If I come over to students, what I could do is I could say, hey, well, now I need a property that will handle the school ID. This should only return a string, and it should return self dot school ID. Jesus, come on. There it is. And otherwise, I should have a setter of school ID dot setter, which should manage the school ID by taking in self a value, which would again be of a string and return nothing. And all we're going to do here is we're actually going to utilize the class. So I'm going to say self dot handle ID. We're going to pass in the value to that. If that doesn't raise a value error, then we could simply go into self dot underscore school ID is equal to the value. This getter and setter is going to look very similar in staff, with the exception that instead of school ID, we are looking at employee ID. All right. And that is it. I now have my inherited class of people that holds the majority of my getters and setters, or at least have some sort of class methods to handle those value errors. I have my staff, which is inheriting from people, and I have my students, which is inheriting from people. That was a lot, so I hope there's a lot of questions. I'm going to go ahead and pause here and open it up for questions. How's everybody doing?
Jason, I feel like you had your hand up for a while. I don't know if you ever got your question answered.
Yeah, he did answer it, but I got another one now. I missed the class when you covered inheritance, so like I got a couple. So you did in the people file, that's where you built like the that piece right there, line 15, I think it is, for the handles ID. Is that what you're referring to of like the inheritance? You build it there, and then you carry it over, in a sense.
Yeah, I build it here, so pretty much any other class that
Yeah.
borrows people has access to it.
Okay, and then the super. Can you briefly explain why we place super here on line 12 for me?
Yeah, so because we are initializing a student, we also need to initialize people. Otherwise, it's going to break. Super creates the connection between student and people so that we don't have to pass in self. And then we just pass in the parameters that we need so that the people class can work properly.
So pretty much super is a connector in this overall.
That's right, yeah.
Okay.
Any other questions? Okay, we're almost to the end, everyone. Let me check. I think I might have jumped the gun in a couple of things, but that's okay. Let's finish reading part one. All right, so we release it, and it's saying, hey, you should be able to create a student with the following arguments. Well, I don't need that student portion anymore because we know that if I'm creating a student, it's a student. And then it walks me through a little bit of the structure. Okay, great. Okay, so now it's having me do a little bit of organization with my folders. That is completely okay. Let's make a directory named classes. Inside of that classes directory, I'm going to move everything with the exception of the running. Okay. So let's move people into classes. We're going to move students or staff into classes. We'll then move students into classes. And finally, we have school that we need to move into classes. All right, because we're moving all of those, we're going to need to go into those independent files and update their import statements. So I'm going to go into classes. People is fine, is not importing from anywhere. School is also not importing from anywhere. Staff is importing. This is coming from classes.people. Students is also importing, and this is coming from classes.people. And then finally, we can go ahead and dive into our runner, which again is coming from classes.school. Let's make sure this still works. I'm going to go ahead and run my runner. Okay, Richmond High still working. Fantastic. Okay, we've done this. We've reorganized all of our classes so that we have our data. And now we just need to load the data. Awesome. So we're going to load that data by reading CSVs. Because we're loading the data by reading CSVs, this is going to take a considerable amount of time. So let's go ahead and take a break. Currently right now it is 3:23. Let's take a 10-minute break and let's reconvene at 10:30, oh, excuse me, at 3:35 to continue on with the review, everybody. Thanks so much, and I'll see you guys shortly. All right, I see there's a lot of the student body still missing. I'm sure they'll be back here shortly, but let's go and get started and continue on with our review. So there was a question while we went on break about, hey, how can I visualize this, right? And I'm personally a big fan of TL Draw. It really helps me out a lot, just be able to visualize everything. So I kind of created a map of what we're interacting with so far. Right, here we have our class of people, along with some properties and attributes that it's interacting with. From there, we have our class of student and our class of staff, where their only unique properties are student ID and employee ID. Right? Other than that, everything else is being inherited through the class of people. And you can see we have those insertions there. Here I have my runner. My runner is using the school class, but it's not necessarily running composition or anything like that. It's just using the school class. My class of school, as of right now, is holding the attributes of name, students, and staff, but it's not actually holding anything to them just yet. And it has no methods. Right, so this is currently where I'm at. This is what we've built out so far from a higher level so that we can see it more as a visual aid. Hopefully that helps out a bit. All right. So let's go ahead and keep going with our assignment. Let's see what my assignment's asking me to do. Yeah, take a look at my documentation. I'm still in part 1 of my assignment, which is completely okay. If I scroll all the way down, my assignment is asking me now to read the data that is inside of my CSV files. Once I can read the data, they should be set to the value of staff and students. So that means that staff and students, so let me grab those, should be used through composition for staff by my class of school. I could just make this super large so that I can fit it if I could figure out how to click. There you go. And through composition, I should also have students. Inside of my school. All right, and I could even add some nice little arrows telling me, hey, students ties to staff, or excuse me, to students, staff ties to staff. All right, well, now let's make that happen. Oh, and I see we have a hand up. Go ahead, Jason.
So for best practice is always essential or try to figure out a way to put your inheritance in a different file so that we can access it. essentially.
I'm sorry, one more time. I don't think I understood that.
So I'm just wondering if it's best practice is always try to put your inheritance files, like separate them from the main code base. So that way we can access. Is that best practice or is it just for this case scenario?
Yeah, that's always going to be best practice, right? So whenever you're looking at it, look at it from a single responsibility principle, right? A class of student, it's its own class. And it's probably going to get pretty complex as I start working through it, right? We need to start managing grades. We need to start doing all kinds of other things. So that should ideally belong at the very minimum in its own file, if not in its own directory, right? And
Okay.
then same thing could be said for staff, and same thing could be said for people.
Okay. Thank you.
Of course. All right. So now let's dive into the next portion here. Here I have my staff class, which holds everything that I need to actually be able to create some staff. And I have my student class, which is pretty much a mirror version of my staff, with the exception that it's meant to handle students. Right? They have a school ID, where staff has an employee ID. But my school should be able to hold these. So I should be able to say, hey, from classes dot student, I need to import students, and from classes dot staff, I should import staff. And these lists that I have here should be holding a list of students, and this here should be holding a list of staff. How do I generate this list? Well, this school already has some data that has been shared with me. These are my staff, and these are my students. So now all I need to do is actually load the CSV files. I'm going to create this logic here within the staff. And what I'm going to do is I'm going to create a class method that will take care of this. This class method is going to be called load CSV data. And it's going to accept CLS and also the name of file. This should be a string, and this should output a list of students or a list of staff. All right. Now, because I'm going to be working with CSV files, I'm going to need to import CSV. Now I'm going to work with a CSV file. I'm going to actually read it. Whenever I'm working with files, I always want to use with open. And I'm going to specify the file that I want to actually read. This is actually looking for a file path. Well, because this is executed from the runner, I'm going to make my path from the runner. I'm going to say, in here, we have a directory named data. And in this directory named data, we have a name of file dot CSV. I want to open it in reading mode. And I want to open it with the alias of CSV file. As of right now, if I print CSV file, I think this is going to work. It may cause an issue, but let's actually check it out. All right. I'm going to go ahead and dive into my runner, and I'm going to test this out. I'm going to run, hey, school dot load CSV data, and I'm going to pass in students. Okay, so there was definitely a print statement there. And you can see that that CSV file is being interpreted as a text IO wrapper name. Here's the path to the name. It's opening and reading mode, and it's encoded in UTF-8. Great. Bunch of gibberish that does absolutely nothing for me. Fantastic. Well, I'm glad I got that portion, right? Let's actually try to read it a little bit. I'm going to come back over to my school, and in my school, I'm going to assign it to a reader. because I need to actually read this file. I'm going to read this file using DictReader. And now, inside of my reader, I'm going to pass in the CSV file. Now let's print out reader. Well, we're getting a step closer, right? My line of gibberish has decreased. It's a little bit smaller now. First, I had a bunch of crap that I didn't really know what it meant. It's just essentially telling me, hey, you opened a text file and you can reference it by the alias of CSV file. Now I have an object from DictReader, which is essentially telling me, hey, you're reading a text file with DictReader. Okay, cool. But I need to know the contents of it. Well, the DictReader is actually returning to you a list of dictionaries. So because I know I have a list of dictionaries, I can say for object in reader, and I don't like that. Let's actually turn that into dictionary in reader, and let's just print the dictionary. Look at that. We have an exact one-for-one match for every student entry of this CSV file into a Python dictionary. Nice. Does anyone have any questions over how we read this CSV file? All right, doesn't seem like we have any questions. So if it works for students, I wonder if it also works for staff, and I should probably check that, right? So let's run it. It did also work for staff, so I'm not running into any issues there. This function so far is pretty dynamic and it works with both of them. Great. Well, now I actually want to load these as a class. So let's go ahead and create a container, which is going to be a list. And here we could probably write a couple of if statements. Well, we know that for a fact, we don't need the rule. All right, if I come back over to my staff class is no longer accepting role as an argument because I'm passing it in as a default. And same thing for students. Students is no longer accepting role as an argument because I'm passing it in as default. So I need to make sure that I account for that. Because if I pass in role into my constructor, it's gonna throw a fit. It's gonna say, hey, well, you're giving me too many parameters, and I have no idea what to do with this. So I'm gonna go ahead and delete from my dictionary the key of role. Nice. Now I can state, hey, if my name of file is equal to students, well, then I want to actually make sure that I iterate and create some students. So I'm going to say new class, or let's call it new instance, is equal to student with the start direct with the destruction of the dictionary. Else, new instance will be of a staff with the destruction of the dictionary. And just to make sure that this is within the appropriate scope, I'm going to name it outside and then just use variable reassignment. Finally, at the end of this, I can say, hey, my container needs to keep track of this. We could pass in the new instance. And at the very end of my function, I could return, and I think that's too far to the left, it is, the container. All right. Well, now let's go into my runner. Let's wrap this up and put it in a print statement. Now, when we run it, we ran into an issue here. So we see that age must be of an integer. Fantastic. So definitely need to make sure that I mutate that because my CSV reader is reading everything as a string. So I need to change that. I can say, hey, DCT, we have the roll of age is equal to integer DCT, the roll of age. Let's see if we have any more errors. And now we get all of our staffs being printed into the terminal. Let's make sure that this works as well for students. And it does also work for students. Nice. But that's not what my assignment is asking me to do. Well, in my school, I'm going to change the values that I'm setting everything to utilize self.load CSV data for students. And then I'm going to use self.load CSV data for staff. Now in my runner, rather than printing school.name, I'm going to print school.staff. And all of my staff gets loaded straight into my school. And if I run students, all of my students are getting loaded straight into my school. All right. So there we go. We have our connection to students through composition. But I do definitely want to make sure that I annotate that I have created one singular class method where this class method is taking care of load CSV file. It takes in a string and it outputs a list of students or staff. All right. Let me go ahead and take a look at my documentation for part one to make sure that I've led us all the way to the very end. Okay, move classes. Here's our staff. Great. Boom, boom, boom. And yeah, we are good to go. We have completed the very first assignment. Does anyone have any questions regarding everything that we've done up to this point before we continue into the next one? All right, let's go into the next one then. Let's take a look at our very next portion. So in this assignment, we're going to actually release the menu. Cool, I'm just going to go ahead and grab this menu. Let me bring it into my code base. Okay, good. It's not. And actually, it doesn't tell me where. Let me take a look here. I should probably finish reading. So in runner py, I'm going to create my menu. Okay, nice. It's telling me just to utilize a couple of if statements. I'm going to make this a little bit fancier. I'm going to use a while loop. I'm actually going to put it into a function called run the menu, where essentially while true, meaning that it's going to keep running forever. I should have an exit code, but let's actually bring in our menu. So let's say menu, which is set to a string, should hold the following. All right. If my input, so user, let's just call it choice, is equal to input, and that's going to grab for utilizing my menu. If choice is equal to 5, then I should break. Else, I probably want some sort of print statement of you must choose from 1 through 5. All right. This is the menu that I have. Let's actually call this function and make sure it works. Let's run the menu. And I'm going to comment out the print statement for student. All right, here we can see it. Here we have what would you like? If I press in 1, it's probably going to give me you must choose between 1 through 5. I could pretty much put anything in here and it's going to tell me to choose between 1 through 5. Even if I choose within 1 through 5, I haven't created the functionality for it. Right now, the only option that exists is 5. 5 will break me out of my menu. All right. Now, what we're going to have our user choose, great. Here we have our Richmond High. List 1 should list all of its current students. Awesome. And let's see what that should output. It should output somewhere along these lines. So this is the F string that I'm going to be chasing here, which it looks like it's a numbered list along with the name and the student ID. So let's build that out in school. This here should be an instance method. So this is going to be, what are we looking for here again? It was list students. Nice. So this should be list students. That should take in self. This is not going to output anything. It's quite literally going to print each independent student. And what it's going to do is it's going to say for stud in self.students. I'm going to go ahead and print an F string. Ooh, and I'm seeing there we have this I. So instead, I'm going to go ahead and do IDX. I'm going to go through the range of len of students. And I'm going to go ahead and create stud being self.students at IDX. I did that so that I can go ahead and just grab IDX plus 1, and I don't have to worry about the list. I can then grab stud.name, and I can grab stud.school ID. All right, let's make sure this works by actually implementing it. We're going to go ahead and make our first if statement, or I guess our next is if statement, where we're going to do an elif choice is equal to 1. Then we should call school dot list students. Let's try it out. So here we run it. We have our class. We press 1. And there we can see that it lists all of our students. This one is my input. And then it continues to print out my students and takes me back to my menu. All right. Again, if I type in gibberish, it's just going to tell me, hey, you must choose from 1 through 5. If I type in 1, it lists out my students. And if I type in 5, it breaks me out of my while loop. All right. Any questions regarding the list students method? Perfect. In that case, let's go ahead and continue. Now we need to have the ability to view a single student. We're going to ask for a student ID, and we're going to pretty much implement this exact elif statement here. So let's grab that. I'm going to bring it into my model. And now I want to account for 2. Instead of mode, I ended up using choice. All right, in the case that choice is 2, I should be able to grab a student ID. Nice. And I should be able to look for a student. Next, I should be able to print the student. Now, I wonder what that print outcome should look like. Well, when I go to print the string of student, that probably needs a string method. There it is. So here's my string method that I'm going to need. Nice. Okay, so it looks like my very first change needs to happen within the student class to make sure that I have this string method. This is going to take in self, and this is going to return an F string, probably a multi-line F string of the following, where age should be self.name, or excuse me, where name should be self.name, age should be self.age, and then finally ID should be self.school ID. So there's my string method that has been updated. If I go back to my runner, it says, hey, we should be able to find a student. Nice. I'm going to come over to my school, and here I'm going to go ahead and make my find a student. So I'm going to make my method find a student. Let me make sure that that's actually the name that we're looking for. So find student by ID. So I should just copy this. All right, so find student by ID. Again, it's going to be an instance method. It does take in an argument from what I can see there. It takes in the student ID. So let's go ahead and look at the ID. And let's just call stud ID. And from here, what we're going to do is we're just going to conduct linear search, right? So I'm going to say for stud in self dot students, if stud dot school ID is equal to the stud ID, then we'll go ahead and return the entire stud. Otherwise, we're just going to return none. So that kind of leads me to a new step here in my runner. This is assuming that I'm always going to return a student. So I should have a, hey, if there is a student, then please print out the student. If there is not a student, then we should print, hey, we found no student with this ID. Let's make sure that works. I'm going to go ahead and execute this. I should still be able to view all students. So let's just go ahead and grab Lisa. I'm going to copy that ID. I'm going to go into grabbing an independent student. It's asking me for a student ID. And there we can see that Lisa is being printed out. If we try to type in some gibberish, it's going to say, hey, we found no student with this ID. Nice. If I try a different student other than Lisa, let's try out Doug. Well, Doug also populates, which Doug is a pretty old student. All right, and we can quit. That was a lot of material that we just covered. At this point, does anyone have any questions over how we implemented the find student by ID method? This is all pretty self-explanatory to you all. Everything's going pretty well. Can I get a show of thumbs up if we're doing well? All right. It's looking pretty good. Okay, perfect. In that case, let's go ahead and continue. I'm going to go to part 2, and we pretty much completed the entire part 2, just in that one moment. So now part 3 is going to be our final part, where in part 3, we should be able to add a student. That's going to be, that's a kind of a monster there. All right, but that's okay. We're going to go ahead and add a student. And then we're going to be able to delete a student. So it looks like those are our final two options. All right. We're going to do our if statement, which is going to be choice. And in this case, I'm going to go ahead and tackle down 4 first, which is just simply removing a student. And I want to remove by element, which I can't remember off the top of my head how that works. I'm pretty sure it is the remove function list.
Sir, I think it's the pop function.
I
The
think
dot pop.
pop works by index.
Is it by index? I can't remember.
Yeah,
But
not
I
by
might be wrong. You might be right.
Yeah, remove is by value. So I'm looking for a remove. Fantastic. All right. So here I'm going to go ahead and say, hey, we want to remove a student. So I'm going to go ahead and print, let's remove a student. I'm going to take the student ID just like I did before here. And once I have the student ID, I can pass it in into school dot remove student by ID. This is going to take in the student ID. And let's create this method. I'm going to come over to the school. In here, I'm going to create a brand new method. This new method is going to be remove student by ID. It's going to take in a stud ID, which should be a string. And we are going to return, I guess we could return a string to show success. All right. Now we're going to go ahead, success or failure, either works. Yeah, let's just do Boolean so that we can show success and failure. All right. So now I'm going to go ahead and iterate through each one, kind of like how we had linear search. So for stud and students, I apologize, this should be self.students. Totally forgot to pass in self. All right. If stud.school ID is equal to the stud ID, then we're just simply going to say self.students.remove stud, and we're going to return true. Whoa. Otherwise, we will return false. We can go back to our runner. We can assign this to something like success. And we could say, hey, we're going to go ahead and state if success. Then we could print out student has been removed. And then otherwise, we could say print could not find a student matching ID. Let's test that out. I'm going to go ahead and run this. I'm going to run the list of one so I can actually visualize a student ID. We're just going to remove Doug because he's last. So be it. I want to remove a student. Okay, so let's remove a student. Give me your ID. Here is the ID. All right, student has been removed. Let's make sure that that's true. It is very true. It was removed. Great. And now I can go ahead and quit. So there's my remove a student method. I'm already starting to realize a couple of issues, right? Ideally, I think rather than storing all of my students and all of my staff in a list, I think a dictionary would have been a much better decision where the IDs were the keys and then the class instance was the value. But we are here now. All right. Now I'm paying the price for not using the right structure. Finally, we can make our method for being able to create a new student. So print, let's create a student. This print method should utilize something like, hey, self.add a student. And instead of self, this should be school. Now, I'm not really going to add much more than that in here just yet, because I'm going to work through this add a student method. I definitely don't like the way that the README has it marked down. It's not really the best way to go about it. So let's go ahead and go through this and create our method. So here we have our add a student method, which is going to take in self. And here it should leverage something like, hey, my student is equal to student dot create stud. And from there, what I can do is say self dot students dot append student. And we could return a success. All right. Awesome. Now this create stud, I'm going to create it within the student class. And I'm actually going to create it as a class method. So I'm going to create a class method where we have our create student. This should take in CLS. And what this is going to do is it's going to build a dictionary. So build stud. In here, what I need is name, which should be set to an input of provide the student's name. We don't need role, which is great. We are going to need age, and it should be typecasted. So we might need a separate method for this. This may be a static method called capture age. This static method is going to ask for input. So age is equal to input of, oh man, I could just done this portion. All right, so provide student age. From there, I probably want to do something stating, hey, for character in age, if not, character dot is numeric, then we want to return ourselves. So capture age. I'm not going to give it an option to get out. So I'm going to say student dot capture age. But I am going to print, hey, all values within here should be numeric. And if it passes, then I'm going to go ahead and return age. But I'm going to return it as an integer. All right. So now my second input here, instead of name, I'm going to capture age. Let's see, what else do we need? I'm going to need a school ID and a password. Okay, so school ID, which is pretty much going to follow the same thing here. So I guess I could have this, I could mutate this. So capture nums, and then maybe I could have it take in a name parameter, turn this into an F string, tell them, hey, we want you to provide the name parameter. Rather than age, we could call a value, but this is okay. So maybe we don't want to cast this into an integer here. I'm just going to go ahead and cast it later on. So here, I'm going to cast it into an integer. In school ID, I'm not. And I need to make sure that I'm passing in, hey, we're looking for H. Here, I'm going to pass in the student dot capture nums. Oh, probably want to change that naming as well. And this one is going to be password. It's not going to be password. It's going to be school ID. All right. And then finally, the last thing that we have to worry about, which is our password. Once I have my create stud, so now once I have my dictionary, I can actually return an instance with my build of a stunts. All right, so this is going to return an instance of the class of student. Nice. I can come back over to my school, which my school is saying to add a student. This is going to create a stud. We're going to append the stud and then return it as true. I think my logic makes sense. I may be wrong. Let's try to figure this out. In my runner, I'm already going to add a student through option 3. I'm going to go ahead and run it. I'm going to go straight to option 3. Student name, FR, student age. If I type in something like FR, okay, so it looks like it threw an error. This is happening inside of my student class. I'm calling something called capture age somewhere. And what I meant to call was capture nums. Let's try that one more time. So 3, student name, doesn't matter. I type in some gibberish. Okay, I still get one error telling me, hey, we still need the positional argument. So I'm going to go ahead and pass that down as well. 3, do some CRUD. We do some other CRUD. Hey, all values within here should be numeric. Okay. Provide the student's age. Good. The age is going to be 27. Provide the student's school ID. Hey, we're going to pass in some garbage in there. Tells me, hey, this is supposed to all be numeric. Great. We make it all numeric. We pass in a password. And now when I go to view all students, I should be able to see the brand new student that I created. If I want to delete the brand new student that I created, I could type in 4, put in the brand new student's ID. I get it, they have been removed. And if I check, they have in fact been removed. And finally, I can quit. And that is the entire student assignment, all the way from part 1 to part 3, everybody. At this point, does anyone have any questions over any of the material that we've covered? Took me a little longer than expected. I apologize. Send it, Kaylee.
I noticed Doug was added back into the student list after he was removed. Was that intentional?
Let's try it out. So if we go through, right, we're gonna go ahead and run this. I'm gonna go ahead and view all of my students. I should see Doug. I'm gonna copy that. I'm gonna remove Doug. So, oh, I accidentally clicked the wrong option. Let me run that one more time. What I'm doing here is I am removing a student. So this is 4. Let's remove Doug. If I type in 1, Doug is gone. Let's go through and create a new student, right? So let's go through 3. We go through it. 12, 12, 12. And then we go to list all students. Doug is gone. I think what might have happened is maybe I quit, and then when I came back, and ran it again. Now Doug is back present. And that is because every single time we start this script all over again, it's reading from my CSV files again, right? Because that's part of the initializer method. If I wanted it to be a permanent change, anytime a student is added or removed, I would have to rewrite the CSV files with the appropriate values. Does that answer your question, Kaylee? All right, perfect. Any other questions? Okay, doesn't seem like we have any questions, everyone. So let's go ahead and stop our recording here.